Okay, so in this video, I'm going to go through example 2b from 3-day 1, so piecewise functions. This is that extra example that you can watch if you wanted to get some extra practice with this procedure. So I have a piecewise function with 3 pieces. I've already set up my t-charts for each piece and written the domain and the function. So what we're looking at here is the piecewise function that has a first piece that is the graph of 2x plus 5 between the x values -6 and -2, where they're both included. So that's telling us that at -6 and at -2, we should have solid points. Let me fix that negative there. Remember that 2x plus 5 is a linear function. Why it's not writing? And so that tells us that we just need to use the endpoints in our table. So I'm just going to use the -6 and the -2 when I'm writing my points. So this graph is going to go from -6 to -2. So I need to plug -6 into my equation, which is 2x minus 5. So 2 times -6, plus 5. So that's -12 plus 5, which is -7. So I have the point -6, -7. It's solid because that was equal to. And then I plug in -2 into my equation. So 2 times -2 is -4, plus 5 is +1. So I'm going to plot the point -2, +1. And again, it's filled in because that was equal to. This is a linear function. I know that because it's just x, not x squared, like in the second piece. So I can just connect those 2 points as a straight line. And so that is the first piece, the graph of 2x plus 5 between -6 and -2. The next piece is, as we just said, quadratic. So if I have a quadratic graph, and I know that because it's squared, I want to use values between my endpoints. Use all values. Okay, so my endpoints are from -2 to +1, not included. So that means that both of my endpoints will be open dots. Remember that the open piece is only the endpoints. I always have a solid line between them. So I need to plug in -2 to +1. I want to plug in each x value between there. So that means I also want to plug in -1, 0, and 1. So I'm going to plug in -2. I'm going to plug in -1, 0, and +1. Okay, so let's substitute those in so we can get our values. So 2 times -2 squared -7 gives us 1. So -2 squared is 4, times 2 is 8, -7 is 1. So at -2, +1, I'm going to have an open dot. We already have the filled in dot from the green piece, so I can just draw a circle around that. Next, I'm going to plug in -1. So 2 times -1 squared -7. -1 squared is 1, times 2 is 2. -7 is -5. Okay, so I'm going to plot the point -1, -5. When I plug in 0, 2 times 0 squared is 0. -7 is -7. So I'm going to have a point at 0, -7. Remember, these are regular points. I know it doesn't really look like it. And then when we plug in 1, 2 times 1 squared is 1, times 2 is 2, minus 7 is another -5. So at 1, I'm going to have a point at -5. This was the end point, so it's open. So remember that it was open here, open here. All of those are solid and connected between there. So I have a parabola. So I know that the shape should be a curved U shape to connect my 3 points that I graphed. Sorry, 4 points that I graphed. Okay, next we've got the third piece, which is -4 minus x. So x is to the first power. That's also linear. So since it's linear, I only have to plug in my 2 endpoints. So I only have to plug in 1 and 3 to get my points, and then I can connect it with a straight line. So when I plug in 1, I've got -4 minus 1 is -5. It's equal to, so I'm going to put a solid point there at 1, -5. So 1, -5 matches up with my previous point, so I'm filling that guy in. And then I have -4 minus 3 gives me -7. And that is also filled in because I have an equal to in my domain. So at 3, I'm going to put a point at -7. And I'm going to connect those 2 points with a line because I had a linear function. Okay, so those are my 3 pieces. Remember, if it's x to the first power, I just need to plug in the 2 numbers in the domain, the beginning and the end, connect them with a straight line. If I have something squared or maybe an absolute value, I want to plug in all the values between so that I can get that parabola or the V shape. So if I look at my graph across for the domain, from left to right, my graph starts at -6, and it's a filled in dot. Notice that all of the holes are filled in. So my graph connects all the way across until I reach an x value of 3. So my domain goes from -6 to +3. Range, so remember that I'm looking this way for domain. For range, I'm looking from bottom to top. So the bottom of my graph, I have points at -7. So my range starts at -7. Again, they're all filled in points, so it's included at least, if at least one of those is filled in, it's included. And then if I go up, I have points everywhere until I hit 1. My maximum value here is 1. Again, it's also filled in, so it's going to be a bracket. So my domain goes from -6 to 3, and my range goes from -7 to 1. Remember that the idea of increasing means that as I look from left to right, my slope is going up. So if I think about that, that's this section of my graph and this section of my graph. Okay, so between 2 different sets of x values, my graph is increasing. So my graph starts out as increasing. So my first domain value is -6. That should be my first increasing value then, if it's starting on the left. It goes until it reaches an x value of -2. Once it hits that x value of -2, it starts to decrease. So the decreasing section starts at -2. And then notice it's decreasing until it reaches that vertex, which has an x value of 0. So it's decreasing from -2 to 0. And then at 0, it starts to increase again. So then it's increasing from that x value of 0 until the x value of 1. And then it starts to decrease again. So I have a negative slope from the x value +1 until the x value 3. So those are my answers for domain, range, and increasing and decreasing for this piecewise graph.